At this very moment, something extraordinary is unfolding within our solar system. An ancient traveler originating from a distant star system is currently moving at speeds of around 200,000 km/h. This object, named 3IATLAS, is currently under bombardment from a massive cloud of plasma ejected from our own sun. But here's the kicker. The entire collision is happening right now, but it's hidden from our view. The comet has vanished behind the sun, and with it, all telescopic observations from Earth and satellites in orbit have become null. This is no science fiction tale. The visitor is 3IATLAS, the third confirmed interstellar object detected passing through our solar system. What makes this event so exceptional is the fact that NASA has been forced to activate its planetary defense protocols for the first time, but this time, it's not due to an asteroid or any other threat to Earth. It's an object from another star. Scientists are in the midst of trying to explain the physics at play, as this event defies almost every rule we've learned about cometary behavior. To set the scene, consider the following. On October 23, 2025, Russian astronomers detected one of the most powerful solar flares in recent history. The flare occurred on the far side of the Sun, invisible from Earth's viewpoint. The explosion's energy was estimated to be at least 10 times more intense than the typical X-class flares we regularly observe. This was a massive eruption of superheated plasma shot into space at speeds nearing 2 million km/h. However, here's where things take a turn for the bizarre. This cloud wasn't directed towards Earth, but rather it was aimed precisely at the position where 3IATLAS was located at that moment. The scientists calculated that the plasma would hit the comet roughly 24 hours later, giving the object a direct encounter with this powerful solar storm. What's strange is the timing. This blast occurred exactly when 3IATLAS was positioned to intercept it. It's a bizarre coincidence that's enough to make even the most seasoned scientists stop and wonder about the forces at play. A comet that is over 7 billion years old is about to face one of the most intense plasma storms our sun has produced. What will this do to it? Will it break apart or shift its course? Is it a natural object, or could there be more to it? These questions loom large, and that's why NASA, in a historic first, has activated its planetary defense protocols. The urgency of the situation is not just about tracking and observing an asteroid, but about an interstellar object from outside our solar system. This decision marks the first time Earth's defense system has been engaged for something originating outside our own star system, a monumental step in space exploration. The object's discovery dates back to July 1, 2025, when it was first spotted by the ATLAS telescope system in Chile. Initially, there was nothing out of the ordinary. Comets and asteroids are frequently discovered, so this was thought to be just another routine find. But within hours of tracking the object's orbit, astronomers realized something was wrong. The trajectory didn't follow the expected path for a typical comet. The object's hyperbolic trajectory suggested that it wasn't bound to the sun's gravitational pull. It had come from another star system. This was the third confirmed interstellar object to be detected in human history. The first interstellar visitor, Oumuamua, was discovered in 2017, and its peculiar cigar-shaped form and unpredictable acceleration sparked a whirlwind of speculation. The second, Borisov, was discovered in 2019 and appeared to behave more like a typical comet, which was reassuring for scientists. But 3I-ATLAS was a different story entirely. It was enormous. Its nucleus is estimated to be between 2 and 6 kilometers in size, making it significantly larger than most comets. This makes it a fascinating object to study, but it's also one that doesn't follow the usual rules. What makes 3I-ATLAS even more perplexing is its unexpected activity. While it's currently located about 3 astronomical units, AU, from the Sun, an area typically too cold for comets to become active, 3I-ATLAS is producing water vapor at a rate of 40 kilograms per second. To put that into perspective, that's the equivalent of filling a large bathtub with water every second. And it's happening at a distance where the sun's heat should barely have any effect. NASA's SWIFT telescope observed 3I-ATLAS in October, and the data they gathered didn't match the expected patterns. Water production at such a distance shouldn't be happening unless something else is generating internal heat. But what could it be? Comets are supposed to be inert, frozen objects. They don't have internal heat sources. So, what could be causing the water vapor? Scientists are exploring several theories. Perhaps the comet is rich in volatile substances like carbon monoxide that can sublimate at lower temperatures. Maybe there's some kind of chemical reaction occurring within the object. Or perhaps the comet has structural cracks, revealing fresh ice beneath its surface. It's possible, too, that the comet captured heat during a close encounter with another star millions of years ago, and is now slowly releasing that stored energy. But then there's the more extraordinary possibility. Maybe it's not a comet at all. This theory was proposed by Avi Loeb, a Harvard astrophysicist, who became famous, or infamous, for his hypothesis that Oumuamua might have been an alien probe. Loeb's focus on 3I-ATLAS has revealed several features that don't fit the traditional comet model. For example, the comet's trajectory is unusually precise, as if it were deliberately positioned for close encounters with planets in the solar system. But it's the acceleration of the object that stands out. Typically, when a comet heats up and outgasses material, it creates thrust, a phenomenon known as non-gravitational acceleration. But the acceleration pattern of 3I-ATLAS is smooth and consistent, far too regular for the chaotic outgassing we expect from natural comets. This leads Loeb to propose that 3I-ATLAS may be performing an Oberth maneuver, a technique used in spaceflight to efficiently change velocity and direction during a close pass by a massive object. Could 3I-ATLAS be a probe from another civilization, executing a carefully planned maneuver to optimize energy efficiency? The possibility is both fascinating and terrifying. The mainstream scientific consensus, however, still holds that 3I-ATLAS is a natural object, a comet from a different star system. Many astronomers dismiss Loeb's hypothesis, suggesting that the anomalies we're seeing could simply be the result of incomplete understanding of interstellar objects. But some of the evidence is difficult to ignore, particularly the object's unusual trajectory and its perfectly timed close encounters with major planets. In the coming months, as the comet continues its journey, we may learn more about its composition and behavior, and perhaps even uncover the mystery behind its peculiarities. But for now, the world is watching closely as scientists prepare for what could be a groundbreaking moment in our understanding of the universe. As 3I-ATLAS continues its journey through our solar system, the mystery surrounding its true nature deepens. To understand just how extraordinary this object is, we need to take a closer look at what makes it so unusual. While most comets follow a predictable path dictated by the Sun's gravity, 3I-ATLAS's behavior challenges our expectations in almost every way. First, let's examine its chemical composition. The moment the James Webb Space Telescope turned its infrared gaze towards 3I-ATLAS in September 2025, scientists anticipated a relatively familiar pattern. After all, comets from our solar system tend to share similar characteristics. They mostly consist of water ice, carbon monoxide, methane, and ammonia, albeit in varying proportions. But when the spectroscopic data came back, it showed a shocking departure from the norm. 3I-ATLAS is producing carbon dioxide at a rate 8 times greater than the water vapor it is emitting. To put that in perspective, in our solar system, even the most CO2-rich comets max out at a 2.1 ratio of CO2 to water. Yet this object is fundamentally different, displaying an 8.1 ratio, an extreme outlier by any standard. This drastic difference suggests that 3I-ATLAS didn't form in the same conditions as the comets we are familiar with. The key to understanding this lies in the star system where 3I-ATLAS originated. Scientists believe that 3I-ATLAS formed in a much hotter stellar environment compared to our solar system. In its original star system, temperatures were high enough to prevent water from condensing into ice but still cool enough to trap carbon dioxide. This suggests that the comet was born in a region where the formation conditions were radically different from the cooler, water-dominated zones of our own system. This discovery is more than just a curiosity. It tells us that planetary systems across the galaxy can vary dramatically in terms of their chemical compositions. While we've only observed 3 interstellar visitors, each one presents a completely different profile. Oumuamua, the first interstellar object to be detected in 2017, was a strange, elongated, and seemingly metal-rich object with no detectable outgassing. Borisov, discovered in 2019, looked and behaved much like a typical comet. But 3I-ATLAS shatters any previous expectations. Its chemical makeup, its trajectory, and its behavior all point to a much more exotic origin. This raises the question, could 3I-ATLAS be a window into a completely different kind of solar system? A place where conditions for the formation of comets are entirely distinct from those in our neighborhood of the Milky Way. The object's carbon dioxide dominance suggests that the chemical processes that took place in its home star system were unlike anything we've seen in our own. This hints at the existence of diverse types of planetary systems across the galaxy, each with its own set of conditions for life and the formation of celestial bodies. To further understand what 3I-ATLAS might be, we need to look at its age. Based on detailed trajectory analysis, astronomers have been able to estimate that 3I-ATLAS is between 7 and 10 billion years old, making it older than our Sun and possibly even Earth itself. While this may sound extraordinary, it's important to consider what this means in the context of the early universe. The galaxy was vastly different back then, with stars forming at a much higher rate than today, and the heavier elements necessary for planet formation were much less abundant. The fact that 3I-ATLAS is older than our solar system suggests it came from a time when the universe was still in its infancy, only a few billion years old. Its journey through the galaxy spans the ages of countless stellar systems, and over the course of its long life, it has witnessed the formation and demise of other stars and planets. This object is a relic from the early cosmos, carrying within it the chemical fingerprint of a now dead star system that no longer exists. What's most fascinating about 3I-ATLAS is that, despite its advanced age, it is still very much active. The freezing cold of interstellar space would typically render objects like this dormant, preserving them in a state of suspended animation. But rather than being a dead rock, 3I-ATLAS is alive with activity, venting water vapor at an astonishing rate, as if it were a fresh comet. This has sparked a great deal of speculation about why this object, after billions of years in the cold depths of space, is suddenly waking up. One possible explanation is that 3I-ATLAS was once part of a larger, more complex body, such as a planet or a large moon. Something catastrophic could have happened, like a massive collision or a close pass by another object, which shattered the larger body and sent pieces of it into interstellar space. These fragments, while preserving the ancient chemistry of their parent body, would be structurally young, recently broken apart and exposing fresh ice beneath the surface. If this is true, it would explain the unusual activity observed from 3I-ATLAS. The surface of the comet could be ancient, but the exposed interior material is fresh and highly reactive, behaving like a newly formed object. There is also the possibility that this is just an artifact of our limited understanding of comets and interstellar objects. After all, we've only recently begun studying these objects from other star systems, and what seems anomalous today may simply reflect the incomplete state of our knowledge. But the evidence so far points to something far more intriguing, prompting scientists to ask whether 3I-ATLAS might be more than just a natural comet. This brings us to the real question. If 3I-ATLAS is not a comet, then what is it? Some astronomers, particularly Avi Loeb, have suggested that it could be an artificial object, possibly even a probe sent by an alien civilization. While this idea might sound far-fetched, it's worth noting that 3I-ATLAS exhibits a series of behaviors that don't fit the natural comet hypothesis. Its trajectory, its acceleration patterns, and even the anomalies in its chemical composition raise questions about the true nature of the object. One of the most puzzling aspects of 3I-ATLAS's behavior is its acceleration. As comets heat up and outgas material, they experience a slight acceleration due to the thrust produced by the gas being expelled. This is called non-gravitational acceleration, and it's a well-understood phenomenon. However, 3I-ATLAS's acceleration is too smooth and consistent to be explained by the chaotic outgassing of a typical comet. Instead, it resembles the kind of controlled acceleration we might expect from an artificial object. If 3I-ATLAS is, in fact, an artificial probe, it could be using a technique known as the Oberth maneuver. This is a real orbital maneuver used in spaceflight, where a spacecraft uses a close pass by a massive object, like the Sun, to change its velocity and direction with minimal energy expenditure. This is exactly what 3I-ATLAS appears to be doing, which raises the possibility that it could be an alien probe, deliberately maneuvering through the solar system for some unknown purpose. However, it's essential to remember that the mainstream scientific community still believes 3I-ATLAS is a natural object. Most astronomers argue that the anomalies observed so far can be explained by natural processes that we simply don't fully understand yet. Still, the possibility that this object is something more than a comet is one that can't be dismissed, especially considering the strange pattern of behavior it has exhibited since its discovery. As we continue to study 3I-ATLAS and monitor its progress, we are faced with a tantalizing question. Is it truly a natural object, or could it be something far more significant, a message from another star system, an artifact of a distant civilization, or just an anomaly that forces us to rethink everything we know about space and comets? The answers may be just around the corner, and in the next part of our exploration, we'll dive deeper into the implications of these questions and what they mean for our understanding of the universe. But for now, one thing is certain. 3I-ATLAS is not just another comet passing through our solar system. It is an enigma, one that may reshape our understanding of both the cosmos and our place within it. The significance of 3I-ATLAS extends beyond its mysterious composition or unusual behavior. It challenges some of the most fundamental principles we have long held about the universe. As we continue to track this interstellar visitor, it becomes clearer that 3I-ATLAS is not only a physical object, but also a symbol of just how much we still have to learn about the cosmos. From its peculiar acceleration to its anomalous chemical composition, this comet, or whatever it may truly be, holds the potential to reshape the way we think about space, time, and the processes that govern the formation of celestial bodies. What makes this situation even more intriguing is that 3I-ATLAS is not just a random anomaly. Its trajectory, as if by design, has brought it on a path that maximizes its interactions with some of the most well-studied planets in our solar system. It passed within close range of Mars in early October 2025, and it will continue on to pass by Venus in early 2026 and Jupiter later in the year. This precise alignment is unusual, to say the least. The object's path takes it right through the solar system's major planets, as if it were carefully planned. The question is, was it? Astronomers often point out that space is vast and orbits are incredibly complex, so such alignments aren't out of the ordinary. However, when an object exhibits other bizarre behaviors, such as the perfectly timed close encounters with these planets, and the anomalies in its acceleration, it starts to seem a little less coincidental. Could 3I-ATLAS be on some sort of mission? Is it possible that, instead of being a natural comet, this object was designed to observe or even interact with specific locations in the solar system? At this point, we are venturing into speculative territory. Yet the more we learn about 3I-ATLAS, the more questions arise. Why is it traveling so directly and precisely through the inner solar system? Why is it positioned in a way that offers ideal observational opportunities, yet is also hidden from view behind the sun at critical moments in its journey? And what of its behavior during those moments when it is out of sight? Is it possible that something is controlling its course, directing its trajectory with far more precision than a natural object could manage? These questions have not gone unnoticed by the scientific community. The idea that 3I-ATLAS could be a probe or some sort of artificial object is a hotly debated topic. Avi Loeb, the Harvard astrophysicist who proposed that Oumuamua might have been an alien probe, has been particularly vocal about the possibilities surrounding 3I-ATLAS. According to Loeb, the object's strange acceleration patterns and trajectory could indicate that it is not a natural comet at all. Instead, he suggests that it might be some form of spacecraft, one that has been carefully steered through the solar system with a purpose that remains unclear. Loeb's argument hinges on the fact that comets typically experience irregular, chaotic acceleration as they heat up and outgas. But the acceleration observed from 3I-ATLAS has been remarkably smooth and consistent. Such controlled acceleration is more commonly associated with spacecraft, which use precise maneuvers to adjust their velocity and course. While this might sound far-fetched, Loeb's observations point to patterns that cannot be easily explained by natural processes alone. The trajectory of 3I-ATLAS, which has brought it in close proximity to multiple planets, further fuels this hypothesis. If this comet is indeed an artificial object, it could be using the gravitational fields of these planets in a way that mirrors a spacecraft's maneuvers. We know that spacecraft use a technique called the Oberth maneuver, which involves passing close to a massive object, like a planet or a star, to gain velocity and change direction with minimal energy expenditure. The idea that 3I-ATLAS could be executing such a maneuver is compelling. It suggests that the object is not simply wandering through the solar system by chance, but is instead actively navigating its path. While this idea is still controversial, it is impossible to ignore the growing body of evidence that suggests 3I-ATLAS is not like any other comet we've ever observed. From its precise trajectory and unusual acceleration to its chemical composition and interaction with planetary bodies, it stands apart from every other object we've encountered in our solar system. But let's take a step back for a moment. What if 3I-ATLAS is not artificial, and it is simply an incredibly rare and extraordinary natural object? This is the mainstream scientific consensus, and it's important to consider this possibility as well. After all, we've only recently begun to study interstellar objects, and our understanding of what constitutes a normal comet may still be incomplete. It's possible that 3I-ATLAS is simply a remnant from a star system that formed under vastly different conditions than our own. Perhaps the unique composition of its gases and its unusual behavior are the result of conditions we've never encountered before. One of the most compelling natural explanations for 3I-ATLAS's strange properties is its age. As we've discussed, 3I-ATLAS is estimated to be between 7 and 10 billion years old. This places it in a time period long before the formation of our own solar system. It has been traveling through interstellar space for an unimaginable length of time, and it carries within it the chemical signature of an environment that no longer exists. This ancient comet has witnessed the birth and death of stars, the formation of planets, and the changing of galaxies. So, what does this mean for us? What can we learn from 3I-ATLAS that will change our understanding of the universe? For one, it shows us that the galaxy is far more diverse than we once thought. Our solar system is just one example of how a planetary system can form, but 3I-ATLAS's composition suggests that there are many different ways for stars and planets to come into being. The galaxy is full of systems that formed under vastly different conditions, and 3I-ATLAS is a fossil from one such system. Its presence here serves as a reminder that we still have much to learn about the universe's rich diversity. Moreover, 3I-ATLAS's journey through the solar system raises questions about how material circulates across the galaxy. It provides a glimpse into the potential for interstellar travel and the movement of matter between star systems. If objects like 3I-ATLAS can travel across such vast distances and still retain their chemical signatures after billions of years, it challenges our ideas about the longevity and preservation of materials in space. The story of 3I-ATLAS is still unfolding, but it is already clear that this interstellar object is unlike anything we've seen before. Whether it turns out to be a natural comet or something far more extraordinary, its arrival in our solar system offers us a rare opportunity to explore a part of the universe we never thought we'd have access to. And as we continue to study it, we will undoubtedly learn more not just about this object, but about the galaxy itself and our place within it. In the coming months, as 3I-ATLAS makes its closest approaches to Venus and Jupiter, we will have more chances to observe it in greater detail. What we learn from these observations could change the way we think about comets, interstellar objects, and the very nature of space itself. But the fact remains, 3I-ATLAS is here, and it is asking us questions we've never had to answer before. What exactly will happen when 3I-ATLAS emerges from behind the Sun? What new data will we collect? Will we uncover answers to the mysteries it presents, or will it continue to elude our understanding? Whatever the outcome, we are on the brink of an astronomical revelation that will shape the future of space exploration for years to come. Stay tuned, because the best is yet to come. As 3I-ATLAS continues its voyage through our solar system, its upcoming emergence from behind the Sun will mark a critical turning point in our investigation of this enigmatic interstellar object. The anticipation among the global scientific community is palpable, as this moment promises to offer answers to the myriad questions surrounding 3I-ATLAS's unusual behavior. But there is still so much we don't know, and that uncertainty only adds to the excitement of what could come next. As we approach the first opportunity for direct observation, the global response has been unprecedented. NASA, along with space agencies around the world, has initiated a coordinated effort to monitor 3I-ATLAS when it reappears in mid-November. Every major observatory, from ground-based telescopes to space-based instruments, will focus on this object with a level of attention never before seen for a comet. The implications of what we might learn are simply too important to ignore. What are we looking for in these upcoming observations? The primary focus will be on the object's trajectory and whether it adheres to predicted orbital paths. We know that comets are often subject to small changes in their trajectory due to gravitational forces, outgassing, and other factors. However, what has made 3I-ATLAS so intriguing is its constant deviation from predicted paths. Every observation has shown that this object doesn't behave as expected, which is part of why the scientific community is so captivated by it. When 3I-ATLAS reappears from behind the Sun, astronomers will conduct an intensive round of measurements using radar facilities like those at Green Bank and Goldstone to track its position and velocity with high precision. These measurements will allow scientists to compare its trajectory with prior predictions. If the trajectory matches expected values within the known margins of error, it would reinforce the idea that 3I-ATLAS is a natural object behaving in ways we don't fully understand yet. But if there are deviations, particularly those that suggest more controlled adjustments, we may be forced to reconsider the nature of this object. One of the most significant aspects of these upcoming observations is the spectroscopy that will be performed. Spectroscopy is the process of analyzing the light emitted or absorbed by an object to determine its composition. For 3I-ATLAS, this means that we will be studying the gases and dust it is releasing, looking for familiar compounds like water vapor, carbon dioxide, and carbon monoxide, as well as potentially unknown chemicals. These analyses will provide valuable insights into the object's internal structure and composition. Already we know that 3I-ATLAS is emitting carbon dioxide at a rate far higher than what we typically see in comets from our own solar system. It is also producing water vapor at an impossible distance from the Sun, leading to the hypothesis that something internal is generating heat. This could be the result of some unknown chemical process, a structural feature that hasn't yet been identified, or even an artificial source of energy. But we won't know for sure until the data is gathered. In addition to the chemical composition, astronomers will be on the lookout for any unexpected changes in the object's outgassing patterns. If the object's surface has been significantly altered by the plasma bombardment it has already experienced, we could see changes in the types of gases it is releasing. Perhaps we will observe new compounds or a sudden shift in the proportions of known chemicals. These could offer crucial clues about what has been happening to the object since it entered our solar system, and especially during the intense solar storm it is currently encountering. But perhaps the most exciting aspect of the upcoming observations is the radio signals. In addition to observing 3I-ATLAS through optical and infrared telescopes, NASA and other space agencies are also focused on monitoring radio emissions. Officially, the goal is to measure thermal emissions, essentially the heat being radiated by the object, which can tell us a lot about its temperature and internal processes. However, there is an unofficial goal that has raised eyebrows, looking for narrowband signals, repeating patterns, or any coherent radio emissions that might indicate artificial activity. It is important to note that this is not the same as searching for extraterrestrial intelligence in the traditional sense. Instead, it's a focused effort to determine if 3I-ATLAS might be emitting signals that could suggest it is an artificial object, perhaps even a probe sent by an alien civilization. The idea is certainly speculative, but the fact that NASA has included this in their observation plan shows just how seriously the possibility is being taken. The fact that 3I-ATLAS has demonstrated such irregular behaviors, including an unusual acceleration pattern and a trajectory that appears highly calculated, means that there is a chance, however small, that we might detect something unprecedented. The scientific community is divided on the question of whether 3I-ATLAS is truly artificial. Avi Loeb, the astrophysicist known for his controversial hypothesis about Oumuamua, has been one of the loudest voices in suggesting that 3I-ATLAS could be a probe. While many astronomers disagree, the fact that Loeb's views are taken seriously speaks to the depth of the mystery. The idea of alien probes is still very much on the fringes of scientific thought, but the increasing number of anomalies surrounding 3I-ATLAS is forcing some researchers to entertain the possibility. Of course, the most likely outcome is that when 3I-ATLAS reappears, it will simply be another strange but natural comet. Its trajectory may still be slightly off from predictions, but within the range that can be explained by known physics and cometary behavior. It might continue to produce water vapor and carbon dioxide in ways that don't fully fit our models, but which are nonetheless consistent with the idea of an ancient object from another star system. However, even this outcome would still be a monumental scientific achievement. we would learn more about the diversity of planetary systems across the galaxy, how comets behave under extreme conditions, and how objects from other stars interact with our solar system. But what if something more significant happens? What if 3I-ATLAS does reveal itself to be something that doesn't fit neatly into any existing category? What if it's not just a comet, but a piece of alien technology or a probe sent by an intelligence that we can barely begin to comprehend? In that case, the ramifications would be nothing short of world-changing. We would be forced to reconsider everything we thought we knew about space and life beyond Earth. The discovery of extraterrestrial intelligence, particularly in such an unexpected and close encounter, would raise profound questions about the nature of the universe, our place within it, and the future of humanity. How do we respond to the discovery of alien technology? Would we attempt to communicate with it or simply observe from afar? And what would the presence of such an object mean for the broader understanding of life in the cosmos? For now, we remain in a state of uncertainty. The data is still being gathered, and the answers may take months or even years to fully understand. But what is certain is that 3I-ATLAS represents an unprecedented opportunity to push the boundaries of human knowledge. As we watch and wait for its return to our line of sight, we find ourselves on the edge of a potential paradigm shift in astronomy and space exploration. In the coming weeks, the mystery of 3I-ATLAS will begin to unfold. Whether it is simply an anomaly in cometary behavior or something far more profound, we are about to learn something new about our universe. The next chapter in this journey will be one of the most thrilling in the history of astronomy. And it's just beginning. As we move closer to mid-November and 3I, Atlas re-emerges from behind the sun, the astronomical community prepares for the next critical phase of this interstellar journey. The anticipation surrounding its reappearance is palpable as scientists around the world brace themselves for the data that will either confirm or challenge our understanding of this object. It is important to recognize that no matter the outcome, 3I-ATLAS has already profoundly impacted our exploration of the cosmos. What happens next, however, could change the course of science, technology, and humanity's relationship with the universe. One of the most intriguing aspects of this unfolding drama is the timing of the event. 3I-ATLAS is passing through the solar system at a time when our ability to observe and study interstellar objects has dramatically improved. In the past, objects like this would have passed by unnoticed or only seen in fleeting glimpses through telescopes. But with the advent of sophisticated instruments and the global coordination of observatories, we now have the capability to monitor such objects in unprecedented detail. This is the first time that an object from another star system has been studied in such a comprehensive and systematic way. When 3I-ATLAS first crossed into our solar system, astronomers quickly realized that it didn't behave like a typical comet. The trajectory was unlike any comet we've ever observed, moving through the solar system on a hyperbolic path, not bound by the sun's gravity. This signaled that it had come from somewhere else, another star system. But the initial excitement quickly turned into confusion as the object began to exhibit behaviors that defied the laws of cometary physics. From its unexpected acceleration patterns to the anomalies in its chemical composition, 3I-ATLAS presented a series of mysteries that scientists are still trying to unravel. The significance of 3I-ATLAS's trajectory cannot be overstated. In the months since its discovery, astronomers have carefully studied its path, noting its proximity to major planets and the timing of its close encounters. For instance, its close approach to Mars in October 2025 was the first opportunity for direct observation, and its journey toward Venus and Jupiter in 2026 will offer additional chances for analysis. Each of these encounters provides a unique opportunity to study the object's composition, behavior, and the forces at play as it interacts with the solar system's gravitational fields. However, the exact nature of its path, seemingly designed to maximize interactions with these planets, raises the question of whether this is merely a coincidence or something more deliberate. Some of the most intriguing features of 3I-ATLAS are related to its acceleration. As comets move through the solar system, they typically experience changes in speed due to the outgassing of volatile materials. This outgassing creates a small thrust, pushing the object in a specific direction. This is what causes a comet's characteristic tail, as gas and dust are ejected from the object's nucleus. However, the acceleration observed from 3I-ATLAS is unlike anything we typically see in comets. It has been smooth and consistent, not chaotic or erratic, like the outgassing of typical comets. This suggests that something more than natural processes may be at play. Avi Loeb's hypothesis that 3I-ATLAS could be an artificial object sent by an alien civilization has stirred significant debate in the scientific community. While the mainstream consensus still leans toward the idea that 3I-ATLAS is a natural comet, the growing number of anomalies raises valid questions about its true nature. Could the object be a probe deliberately navigating through the solar system to observe or gather data? The idea seems outlandish at first, but when you consider the object's unusual acceleration and trajectory, the possibility cannot be dismissed out of hand. In fact, one of the most compelling aspects of Loeb's theory is the possibility that 3I-ATLAS may have used a technique known as the Oberth maneuver. This maneuver is used by spacecraft to maximize efficiency during close encounters with massive objects, such as stars or planets. By using the gravitational pull of these objects, spacecraft can change their velocity and direction without expending large amounts of energy. The fact that 3I-ATLAS's trajectory seems to follow a similar pattern, moving toward the Sun at a high velocity and using the Sun's gravity to adjust its course, suggests that this object may be employing a similar strategy, one that is typically reserved for spacecraft rather than natural objects. This hypothesis raises another question. If 3I-ATLAS is an artificial object, what is its purpose? Is it exploring the solar system, gathering data, or even communicating with us? The possibility of an alien probe, a piece of technology created by an advanced civilization, is a tantalizing one. But the idea is still speculative, and for now, it remains one of many possible explanations for the object's strange behavior. On the other hand, the more likely scenario is that 3I-ATLAS is simply an extraordinarily rare natural object, a comet that has somehow evolved in ways that we don't fully understand. Its composition and behavior could be the result of conditions that we have yet to observe elsewhere. The fact that it has been in space for billions of years, traveling through interstellar space, makes it a unique and valuable object for study. But even if it turns out to be a natural comet, the lessons we can learn from it are still profound. The mystery surrounding 3I-ATLAS is a reminder of just how much we still don't know about the universe. It is a wake-up call to the scientific community that our models of space and celestial bodies may be incomplete. We have spent centuries studying comets, asteroids, and other objects within our solar system, but the arrival of 3I-ATLAS challenges our assumptions and forces us to question everything we thought we knew. For example, the fact that 3I-ATLAS is producing water vapor at such a great distance from the Sun has led scientists to propose several hypotheses. Could the object have an internal heat source? Is there a chemical reaction occurring within the comet that is generating heat and releasing water? Or could the water vapor be the result of some external force, such as the interaction between the comet and the solar wind? The answers to these questions could have far-reaching implications for our understanding of how comets behave, especially those from other star systems. Another major question revolves around the object's age. As mentioned earlier, 3I-ATLAS is estimated to be between 7 and 10 billion years old, older than our Sun and possibly older than the entire solar system itself. This raises the possibility that 3I-ATLAS is a relic from a much older part of the galaxy, one that predates even our Sun. The fact that this object has remained intact for such a long period of time, traveling through interstellar space, suggests that there may be processes at work in the universe that we do not yet understand. The preservation of material over such an enormous time span challenges our understanding of the stability of objects in space and opens up new avenues for research into the longevity of celestial bodies. One of the most exciting aspects of 3I-ATLAS is that it offers a rare glimpse into the diversity of star systems in the galaxy. The composition of 3I-ATLAS, with its extreme levels of carbon dioxide and unusual chemical ratios, suggests that it came from a system very different from our own. The chemical composition of comets is determined by the conditions in the protoplanetary disk where they form, and the fact that 3I-ATLAS's composition differs so drastically from our own solar system's comets indicates that the star system it came from had vastly different conditions. This is a critical piece of evidence that tells us that our solar system is not the only type of system in the galaxy. There are many other types of planetary systems out there, and each one could give rise to comets, asteroids, and other objects that behave in ways we have yet to discover. As we wait for the reappearance of 3I-ATLAS and the crucial data that will follow, the excitement in the scientific community continues to build. No matter the outcome, whether it turns out to be a natural comet or something far more extraordinary, 3I-ATLAS is already reshaping our understanding of the universe. And the answers it provides, or doesn't, will leave an indelible mark on the history of space exploration. The next chapter in the journey of 3I-ATLAS will soon be written, and the world will be watching closely to see where this extraordinary story leads. Whatever happens, we are on the cusp of a new era in our exploration of the cosmos, one that promises to deepen our understanding of the universe and challenge everything we thought we knew. Stay tuned, because the mystery of 3I-ATLAS is far from over, and the discovery of what it truly is will change the way we look at the stars. As 3I-ATLAS nears its closest point to the Sun and continues its passage through the solar system, scientists eagerly await the next phase of its journey. The data from the upcoming observations will be pivotal in answering many of the lingering questions about the object. With each passing day, the anticipation grows, as researchers are on the edge of uncovering something truly extraordinary, or perhaps confirming that 3I-ATLAS is simply an unusually strange comet from another star system. One of the primary focuses in the coming weeks will be to analyze 3I-ATLAS's structural integrity. Comets, especially those from interstellar space, often undergo dramatic changes when they approach a star, as the heat and radiation can cause surface material to sublimate, crack, or even break apart. This is a process known as outgassing, where the heated ice inside the comet turns into gas and escapes into space, often carrying dust and other debris with it. For many comets, this process results in a visible tail or coma. The fact that 3I-ATLAS is already emitting water vapor at an unusual rate, even though it's still far from the Sun, raises important questions about what is happening beneath the surface. NASA and other space agencies will be closely monitoring any changes in 3I-ATLAS's surface features as it moves closer to the Sun. Has the object experienced any fragmentation? Are there signs of new cracks or stress points on the comet's surface? These observations could provide a crucial clue about its internal structure. If 3I-ATLAS is undergoing structural changes, it could indicate that the object is not a simple icy ball, but rather something much more complex. If it remains stable and intact, it may support the argument that it is a natural object that has withstood the harsh conditions of interstellar space for billions of years. Furthermore, scientists will be keenly interested in the object's rotational behavior. Most comets rotate slowly and unevenly, which contributes to the chaotic release of gases as their surfaces heat up. However, the acceleration of 3I-ATLAS has been unusually smooth and consistent. This suggests that its rotational dynamics might be far more regular than that of typical comets. A steady, controlled rotation could point to something else at play, perhaps an artificial component or a structure beneath the surface that allows for a more predictable release of gas. If this turns out to be the case, it could lend weight to the hypothesis that 3I-ATLAS is not entirely natural, as this is not something we typically see in comets. In addition to the physical analysis, the chemical composition of 3I-ATLAS will remain one of the most important areas of study. As we have seen, the object is emitting carbon dioxide at a rate far higher than that of typical comets. It's also producing water vapor at a distance where it should not be possible based on the standard laws of cometary behavior. What could be generating this heat? Could there be an unknown chemical reaction taking place inside 3I-ATLAS? Or is it possible that it is somehow harnessing energy from external sources, like the interaction with solar radiation or cosmic radiation? The chemical composition of 3I-ATLAS will be studied in greater detail using spectroscopic techniques, which allow scientists to identify the specific types of molecules present on the object's surface and in the surrounding coma. Instruments like the James Webb Space Telescope, Hubble Space Telescope, and various ground-based observatories will be focusing on this object in the coming months, collecting a wealth of data that will help build a complete picture of its chemical makeup. The goal is to determine if there are any unexpected molecules or isotopes present, something that might provide a breakthrough in understanding its origin. For example, if unusual organic compounds are detected, It could open up new theories regarding the possibility of life or prebiotic chemistry in other star systems. Additionally, a key focus of the scientific community will be the object's behavior as it moves through the solar system. We know that comets often experience significant changes in speed and direction due to outgassing, a phenomenon known as non-gravitational acceleration. But 3I-ATLAS has exhibited a pattern of acceleration that is too smooth and consistent to be explained by outgassing alone. This has led some researchers to wonder if the object is using a more controlled form of propulsion, one that suggests it could be a probe, a piece of technology, or an object influenced by an external force. As we've discussed before, Avi Loeb, the Harvard astrophysicist, has proposed the possibility that 3I-ATLAS is an artificial object. If this turns out to be true, the implications for our understanding of the universe would be immense. We would have to rethink everything we know about the potential for intelligent life beyond Earth. Could this object be a probe sent by an alien civilization on a long journey through interstellar space to explore the galaxy? The idea is tantalizing, but it remains speculative. The data that comes in from upcoming observations will be crucial in either supporting or refuting this hypothesis. Even if 3I-ATLAS turns out to be a natural object, it will still have profound implications for our understanding of the cosmos. The fact that it has been traveling through interstellar space for billions of years and is still active suggests that the universe is far more dynamic and diverse than we ever imagined. Objects like 3I-ATLAS are relics of ancient star systems that no longer exist. They carry with them the chemical signatures of environments that are now lost to time. Studying these objects could give us unprecedented insight into the conditions that existed in the early galaxy and how different star systems and planets might evolve over time. Furthermore, 3I-ATLAS's journey through the solar system underscores the fact that we are not alone in the galaxy. Interstellar objects pass through our solar system regularly, but they are usually too small or too distant for us to detect. The fact that 3I-ATLAS is large enough and close enough for us to study it in detail offers us a rare glimpse into the diversity of planetary systems across the galaxy. The discovery of 3I-ATLAS is proof that there is much more out there than we could ever imagine. As we continue to explore the cosmos, we may uncover even more evidence of the vast variety of star systems, planets, and objects that exist in the universe. As 3I-ATLAS continues its journey, the next phase of observations will provide us with more data that could either confirm or challenge everything we think we know about comets, interstellar objects, and the nature of the galaxy. What happens when 3I-ATLAS reappears in November? Will we uncover answers that change our understanding of space and time? Or will the object remain an unsolvable mystery? The excitement surrounding 3I-ATLAS is more than just scientific curiosity. It represents the unknown, the unexplained, and the infinite possibilities that exist beyond our solar system. Every piece of data that comes in brings us closer to answering questions that have long eluded us. And with each new discovery, we take one more step toward understanding our place in the universe. One way or another, 3I-ATLAS will help us move forward in our exploration of the cosmos. Whether it is an ancient comet or a piece of alien technology, the knowledge we gain from studying this object will be invaluable. And as we wait for its reemergence, we are reminded that the universe is full of mysteries, some of which may be far stranger and more wondrous than we can ever imagine. The journey of 3I-ATLAS is just the beginning. As we prepare for the reappearance of 3I-ATLAS in mid-November, the excitement around this interstellar visitor continues to build. The wealth of data already collected has prompted a series of new questions, and the forthcoming observations promise to shed light on aspects of the object that remain shrouded in mystery. The coordinated global efforts to monitor 3I-ATLAS will yield invaluable insights, and while we may not have all the answers, each discovery will bring us closer to understanding the true nature of this object. One of the key areas of focus in the upcoming observations will be 3I-ATLAS's interaction with the solar wind and its potential response to the plasma cloud that the object is currently passing through. This cloud of charged particles ejected from the Sun has already begun to impact the object, and scientists are eager to study how it influences the comet's behavior. The intensity of the solar flare that generated the plasma cloud was far greater than what we typically see, and 3I-ATLAS's precise location in the path of this cloud could provide a unique experiment in space weather. Normally, when comets pass through the solar system, they are affected by the solar wind and radiation. This results in the characteristic coma and tail we associate with comets, a halo of gas and dust formed as the comet's ices vaporize and are pushed away by the Sun's radiation. But 3I-ATLAS has already shown signs of being much more active than expected, producing water vapor at a rate that defies the conventional understanding of cometary behavior at such a distance from the Sun. Could the plasma bombardment accelerate this process, causing even more intense outgassing, or perhaps even triggering a structural change in the object? Will 3I-ATLAS survive the intense plasma interaction, or will it fragment and break apart as a result of this unprecedented bombardment? For many astronomers, this is the most exciting aspect of 3I-ATLAS's encounter with our solar system, the opportunity to study an ancient object subjected to forces we can directly observe and measure. We know that objects like comets and asteroids are typically resistant to the harsh conditions of space, but when exposed to the extreme radiation and solar wind near a star, they can undergo profound changes. If 3I-ATLAS were to fragment or experience significant changes in its structure, it would provide us with a rare opportunity to study an object from another star system in its final stages of survival. If 3I-ATLAS remains intact and continues its journey, the data gathered from this encounter will be just as valuable. By carefully monitoring its outgassing and any changes to its trajectory, scientists can learn more about the processes that govern the behavior of comets, especially those that travel through interstellar space. The fact that 3I-ATLAS has already shown such unusual activity, producing water vapor and carbon dioxide in such large quantities at such a great distance from the Sun, suggests that it may be a special case. Whether it is the result of a unique chemical process, an internal heat source, or even something artificial, the answers we uncover from studying 3I-ATLAS could help us refine our understanding of how comets behave, both in our solar system and beyond. Beyond the comet's physical properties, another critical area of investigation is the object's potential to provide insights into the origins of life. As scientists continue to study 3I-ATLAS's composition, they have discovered that it contains a mixture of water, carbon compounds, and possibly even organic molecules. While these are not life forms themselves, they are the building blocks necessary for life as we know it. This discovery has reignited the debate over the possibility of panspermia, the theory that life, or at least its basic components, can spread between planets and star systems via comets, asteroids, or other cosmic material. The idea of panspermia is not new. For years, scientists have speculated that comets could have played a role in delivering water and organic compounds to the early Earth, contributing to the conditions necessary for life to begin. The presence of organic molecules in 3I-ATLAS only strengthens this hypothesis. If material from another star system can carry the essential ingredients for life to a planet, could life have started on Earth as a result of such an interstellar delivery? And if that's the case, could life, or at least the building blocks of life, be spreading throughout the galaxy in a similar manner, traveling from one star system to another, carried by comets like 3I-ATLAS? This idea has profound implications for our understanding of the universe. If panspermia is proven to be a legitimate process, it would mean that the chemical ingredients necessary for life are not unique to Earth, but rather common across the galaxy. Life, or at least the potential for life, could be widespread throughout the cosmos, waiting for the right conditions to take hold. This would radically alter our search for life beyond Earth, suggesting that we may not be alone in the universe, but rather part of a much larger, interconnected web of life, one that spans the galaxy. At the same time, the question of whether 3I-ATLAS could be carrying life in the form of microorganisms or other biological material remains a tantalizing possibility. While it is highly unlikely that the comet is carrying fully developed life, it could still provide a window into the types of conditions that might support life elsewhere in the galaxy. The discovery of organic molecules on 3I-ATLAS could be a sign that similar molecules exist on other comets and asteroids throughout the galaxy. And if life's building blocks are common, the possibility of life elsewhere in the universe becomes much more plausible. Of course, these questions are still far from being answered. As we continue to study 3I-ATLAS and other interstellar objects, we will need to gather more data and refine our models to better understand the potential for panspermia and the spread of life across the galaxy. But for now, 3I-ATLAS represents a unique opportunity to explore these ideas in real time. Its passage through the solar system is more than just an astronomical event. It is a potential turning point in our understanding of life, both here on Earth and across the universe. The potential for discovery is vast, and the data we will collect from 3I-ATLAS in the coming months will be invaluable in answering these big questions. But what makes this journey even more exciting is the fact that we're witnessing a moment in history where we could be on the verge of making a discovery that changes everything. Whether 3I-ATLAS turns out to be a natural comet, an alien probe, or something entirely different, its presence in our solar system is already forcing us to rethink our place in the universe. As we continue to observe and analyze this ancient interstellar visitor, the mystery of 3I-ATLAS will slowly begin to unfold. The data we collect will offer new insights into the nature of interstellar objects, the potential for life beyond Earth, and the diversity of star systems across the galaxy. One thing is for certain, this is just the beginning. The reemergence of 3I-ATLAS promises to be a pivotal moment in the history of space exploration, one that will shape the future of astronomy and our understanding of the cosmos. As we wait for 3I ATLAS to make its return, we are reminded that there is still so much we don't know about the universe. Every new discovery brings us closer to answering some of the deepest questions about our existence. And the journey of 3I ATLAS is only one chapter in a much larger story. A story of exploration, curiosity, and the search for answers to the mysteries of the universe. As the weeks pass and 3I ATLAS continues its trek through our solar system, we approach a pivotal moment in our understanding of the cosmos. The data gathered from its reemergence will answer questions that have captivated astronomers and scientists for years. While the object has already provided us with valuable insights into the nature of interstellar objects and the diversity of star systems across the galaxy, the most significant discoveries are still to come. What happens next will shape the course of space exploration for years, if not decades, to come. One of the most anticipated aspects of 3I ATLAS's upcoming reappearance is the potential for new, groundbreaking discoveries in the field of astrophysics. Since the object's arrival, scientists have been puzzling over its anomalous behavior, its unexpected acceleration, strange chemical composition, and seemingly controlled trajectory. While many of these irregularities have been explained as possible results of its interstellar journey, the fact remains that 3I ATLAS has shown us that the universe is far more complex than we once imagined. The upcoming observations will either confirm our current theories or lead to new questions that could rewrite the textbooks. A critical question in the coming months will be whether 3I ATLAS continues to behave in ways that challenge our existing understanding of comets and their behavior. One of the main objectives for astronomers is to carefully monitor any shifts in the comet's trajectory, especially after it has passed through the solar storm and reappears from behind the sun. For the first time, we will be able to observe the object directly and measure how its path has been influenced by the interactions it has undergone. If 3I ATLAS's trajectory deviates even further from predictions, it may suggest that there are factors at play, be they unknown forces or intentional adjustments, that we don't yet understand. This could provide crucial evidence that 3I ATLAS is not merely a natural object, but something far more intriguing. Could it be some kind of probe or spacecraft designed by an advanced civilization to gather data on our solar system? The idea may seem far-fetched to some, but the growing body of evidence, including the object's controlled acceleration, precise path, and strange composition, continues to fuel the speculation. If it turns out that 3I ATLAS is indeed artificial, it would be one of the most significant discoveries in human history. We would finally have concrete evidence that we are not alone in the universe, that intelligent life has existed elsewhere, perhaps billions of years ago, and that some form of its technology may have survived the passage of time. But even if the object turns out to be a natural comet, its composition and behavior still hold profound implications. Comets like 3I ATLAS serve as relics from ancient star systems, carrying with them the chemical signatures of environments that no longer exist. The fact that 3I ATLAS is estimated to be 7 to 10 billion years old, older than our Sun and possibly even the Earth itself, means that it predates our solar system by billions of years. This offers a unique glimpse into the early days of the galaxy, long before our solar system was formed. The materials and chemicals present in 3I-ATLAS could shed light on the conditions that existed in the early universe. We know that the galaxy was much more chaotic in its early stages, with higher rates of star formation and a greater prevalence of heavy elements. The discovery of unusual chemical compounds, such as the high levels of carbon dioxide and the presence of organic molecules, suggests that 3I-ATLAS may have come from a star system that formed under very different conditions than our own. These compounds could offer us new insights into how planets and stars evolve and the types of environments that may support life. This brings us to another possibility, the idea of panspermia, the hypothesis that life or its building blocks could be transported between star systems on comets, asteroids, and other cosmic debris. If 3I-ATLAS is carrying organic compounds, it could provide more evidence that the ingredients for life are common across the galaxy. The presence of water, carbon compounds, and potentially even amino acids on 3I-ATLAS only adds to the theory that the essential building blocks of life are not confined to Earth, but instead may be widespread throughout the universe. While the discovery of life on 3I-ATLAS is highly unlikely, given the extreme conditions of interstellar space, the detection of organic molecules raises the possibility that comets like this one could have played a significant role in the delivery of life's building blocks to planets like Earth. If the conditions are right, these molecules could eventually combine and evolve into more complex structures, possibly leading to the emergence of life. The implications of this would be profound, suggesting that life, or the potential for life, could be spread throughout the galaxy on the very objects we once considered merely frozen relics of the early universe. For now, the scientific community is bracing for the next stage of observations. As 3I-ATLAS emerges from behind the Sun, it will be scrutinized like never before. Telescopes across the globe, both on Earth and in orbit, will be focused on this object. The data gathered will provide critical answers, not only about the object itself, but also about the processes that govern the behavior of comets, asteroids, and interstellar objects. With each observation, we move closer to unlocking the mysteries of this ancient traveler from another star system. Whether 3I-ATLAS proves to be a natural comet or something far more extraordinary, it is already teaching us invaluable lessons about the nature of the universe. It has reminded us that our understanding of space is still far from complete, and that the cosmos is full of surprises. Even in an age of advanced technology and space exploration, objects like 3I-ATLAS can still astonish us, offering new clues to the mysteries of the galaxy. The reemergence of 3I-ATLAS will mark a momentous occasion in the history of space exploration. It will serve as a reminder of how far we've come and how much further we still have to go. Every piece of data collected in the coming months will add to our growing knowledge of the universe, helping to answer questions we never even knew to ask. And as we continue to study 3I-ATLAS and other interstellar objects, we may one day uncover the true origins of these ancient travelers and the role they play in the larger story of the galaxy. For now, we wait. And in that waiting, we are reminded of the endless possibilities that await us in the universe. Whatever happens with 3I-ATLAS, one thing is clear: this object has ignited a spark of curiosity and wonder that will continue to fuel humanity's quest to understand the cosmos. The journey of 3IATLAS is far from over, and as we prepare for the next chapter, we stand on the threshold of discovery, ready to learn more about the universe than ever before.